guys, welcome back. This is video for review B. I think we got through all of 3, so I think we're on to number 4. All right, it says explain the use of the horizontal line test. I'm not going to write it down, but we'll talk about it. A horizontal line test is when you're looking at a graph and you're trying to figure out, does this guy have an inverse? Well, if I draw a horizontal line across it and I hit more than once, then this function does not have an inverse. The vertical line test is trying to figure out, does a graph itself have an inverse? Or sorry, is the graph itself a function? So this graph here would not pass the vertical line test because when I do the vertical line test, it hits more than once. So therefore, this graph is not a function. To determine whether something is even or odd, you can do 2 different things. Algebraically, an even function, when you plug in negative x into it, it should spit out f of x. So for example, x squared. If I put in negative x and I square it, I still get x squared back. So it gives me back the original function, and that's even. Graphically, I can tell it's even because the parent quadratic function, if I flip it along the y-axis, it is symmetrical to the y-axis. So this piece is a mirror image of this piece. All right, for our odd function, algebraically, I can find that if I plug in negative f of x. If I plug a negative x into my function, I should get back a negative y value, so negative f of x. An example of this one would be x cubed. If I plug in negative x, I'd have negative x cubed. And so that would be negative x times negative x times negative x, and that's negative x cubed. So this is odd. And graphically, that looks like this. It needs to be symmetrical across the origin. So this piece here is a mirror image of this piece. And then finally, sometimes you'll have a function, say x squared plus x plus 1. This function is neither even or odd because some pieces will change the sign when you put in negative x and some won't. So for example, this one here, if I plug in negative x times negative x is positive x squared. But here it's negative x, and here it's 1. So this piece stayed the same, this piece stayed the same, but this piece changed. So this function is neither. It's neither odd or even. It's none of the above. All right, number 7, they want us to find the inverses. So remember, your first step is y is equal to 3 over x. And then I'm going to change my x and my y and solve for y. So multiply times y, divide by x, and I get y is equal to 3 over x. So the inverse of x is 3 over x. For b, again, I'm going to go ahead and change my y and my x in the first step. I would add 5. We're solving for our new y. Divide by 3. So my inverse is x plus 5 over 3. And then finally, for the last one, x is equal to y minus 2 squared. Take the square root of both sides. And I get the square root of x is y minus 2. Add 2 to both sides, so the f inverse of x is the square root of x plus 2. It's nice they've already restricted the domain for you. Keep in mind, this is a quadratic function, so if the domain was not restricted, you could not have an inverse for it, because it wouldn't pass the horizontal line test. All right, let's do number 8 on this video, and then I'll make a new one for 9 and beyond. So given f of x is this, and g of x is this, evaluate the following. So f of g of x, that's what fog means. That's f of g of x would be x squared plus 7. I'm going to plug in x squared plus 7 right here. So that's 3 times x squared plus 7 minus 5. So 3x squared, 3 times 7 is 21 minus 5, 3x squared plus 16. For b, we're going to do the opposite. We're going to plug f into g. That would be g of this guy here, which is 3x minus 5. So instead of x squared, I have 3x minus 5 squared plus 7. All right, 3x minus 5 times 3x minus 5 plus 7. 3 times 3 is 9x squared. 3 times negative 5 is negative 15x. Minus 15x is negative 30x. Negative 5 times negative 5 is 25 plus 7, which gives us 9x squared minus 30x. Don't forget your x in series, plus 32. All right, g of 4. This is kind of interesting. So first we want to find g of 4. So what is g of 4? If I plug in 4 here, I've got 4 squared, which is 16, plus 7, which is 23. So we're trying to find g of 23. If I plug in a number, I should get a number out. When you plug in x's, you should get x's out. So to find g of 23, that would be 23 squared. Well, that's not how you said it, because there's 23 squared plus 7. Now, I expect you guys to know your squares and your cubes, but not all the way up to 23. So let me plug that guy into a calculator, because I don't have that off the top of my head. 23 squared is 529, plus 7 would be 536. All right, that's the end of part 3, and I will get you part 4 after power up.